These days anyone can build an app with AI tools. You write a few prompts, click around for a while and suddenly you have something that looks real. A homepage, login, maybe even a dashboard with data inside. And that's exciting because it turns an idea into something visible very quickly. But it also can create a false sense of progress. The app may look finished while still being difficult to maintain, host or extend. Vibe-coded apps are often a great starting point, but if you want the project to be anything more useful, it helps to think about the foundations as early as possible. A little more structure at the beginning makes the application easier to run, easier to understand and much easier to manage. In this video I will show you a simple way to set up that foundation. We will look at the main layers of a typical web application, how they fit together and how to organize them in a way that works well from the start. As some of you may know, I recently decided to find a way to reduce the number of small subscriptions I need to get work done. With the recent technology shifts where we use more and more agentic workflows, I wanted to use their advantages to build a simple app that helps me keeping my notes organized and shared across the devices, with totally private space for thinking process supported by different AI models. The initial goal is to create a web application where each user should have their own account, and the data will be stored remotely so they can access from any device. The requirements are pretty basic and there will be just one user for now, me, but the primary idea is to show you how we handle similar cases for our clients. So, such a simple user-protected stack usually requires a few layers. A frontend for user interaction, a backend for administration and authorization, database, and the storage for static files. Some applications might skip some parts like the authorization, but the core idea behind this for such headless stacks usually stays the same. A frontend that communicates with a backend connected to specific database and storage service. Each layer in such stack has a specific responsibility, so the connections between matter a lot. For example, the code that runs in the front-end layer in the user browsers should not have a direct access to the database that stores the application data. If it did, the user could potentially access the information that should remain protected and private. So what is the best stack for such kind of application? I won't surprise you, because there is no single best stack. Even when I recommend any solutions, their use varies mainly based on the features the specific system must implement, the client's requirements, and the development experience the project must support. In fact, I often like saying that for a good engineer, there is no difference when using Vue, React, or others. They all share similar principles when building something solid. So for the tech stack here, I'm going to use the mixed technologies that our team already knows well and the few that I want to explore further. That balance helps the project move quickly while still leaving room for experiments. In fact, most of this recommended stack is the one we used for many projects made for our clients at Coditive. So I know from experience that it works well, even for the enterprise level applications. The frontend is the part the customers actually see and use every day. It presents the user interface, shapes the user experience and connects the customer browser to the rest of the platform. I recommend the Nuxt framework because we have successfully integrated it into many projects over the years and we are very happy with the experience and the value it provides. It includes many ready-to-use custom modules, so for more advanced cases or tight timelines, we can reduce costs and handle integrations more quickly. It works perfectly for such layered applications architecture because it supports something called server-side rendering. So we are able to split the frontend into two practical sublayers. Application, which is responsible for the interface and the code that runs in the client browser, and the server, which handles the business operations while keeping the applications responsive and secure, because browsers have access there just through the controlled API endpoints. The backend, or more accurately the back office, will serve as a control center for the application. It connects the frontend to the data layer through the API, controls the user authentication and authorization, and gives the administrators a clean place for managing the system behavior, data structures, or elements that are outside the scope of the standard customers. For content-driven headless websites, we like using WordPress for this purpose because it integrates pretty well with the frontend due to its Gutenberg editor, which is available there. However, for data-driven applications that operate mainly on the data structures rather than on the frontend blocks, Directus is a better choice, so I recommend going with this. We recently successfully used it for a project of more than 1000 hours in sites, and it integrated perfectly with Nuxt. I've been amazed as a developer how efficient it was and how easy it was to build custom data structures there, so it's totally worth trying. The backend layer needs to store its data somewhere. For simple vibe-coded applications, SQLite is often the first recommendation. It is simple, efficient, for smaller apps and integrates well with Directus without any additional work. It's worth trying first if you don't want to overcomplicate the whole infrastructure at the beginning. SQLite is a good first option for start and for experiments, but for this project I will use MySQL as the primary database because it is a stronger fit for structured applications that may grow later. Data is routed through the Directus API, which helps protect the data integrity, enforce business rules, and reduce security risk because the database server is not available to the end customers. And while MySQL is good for relational data, it cannot be used to store static files like images, videos, or other attachments. The first option that comes to mind is using cloud storage like AWS S3. However, be aware that due to its dynamic costs, it might not be the right choice for a vibe-coded application. And this is why I recommend an open-source, self-hosted alternative called RustFS. It is fully S3 compatible, so I can use the official S3 JavaScript SDK without any problems. If it changes in the future, I can simply change the endpoints and the application will keep working. And this layer keeps the file handling separated from the main logic, which simplifies the operations and makes the media storage easier to manage at scale. I choose those tools for this project because they work well together. The connection is flexible enough to adapt as the application grows, beyond the initial expectations. We can replace one node with another and rework the small connection rather than rewriting the entire application just because we changed RustFS to AWS 3. And here's how the layers interact with each other in such flow. The application consists of 4 nodes. The front end with Nuxt that splits into 2 sub-layers that I mentioned. The client that handles the browser operations and the server that handles the business logic. The servers then communicate with the storage node and the backend. As you see, the client's layer, the user browser, has no direct access to the storage or the backend, so it improves the security and maintainability of such application. Then backend communicates with database to store the relational data. I totally understand that as a beginner you can feel confused by all of this, layers, responsibilities, and 4 different tools to use. And you might ask, how to even run it on your local environment? But believe me, it's super simple. In many of our projects, the local environments remains flexible. Developers receive the final system requirements before the project starts, then prepare a local stack to run the project. That can work here as well, but I want to test a little different approach. Instead of relying as much on the system environments, I'm going to use Docker to provide a single stack that runs everywhere. This avoids local config lock-in and reduces potential environment conflicts caused by the different tools versions across developers' devices. It lets us define the project infrastructure once and run it in the same way across the other environments. So no matter if the team uses macOS, Windows or Linux, if they have different node versions installed locally, they will fire one command and the environment starts. And that consistency makes the whole setup much simpler and makes the development also easier as well. If something starts with a single command on the local device, it can do the same in the production environment that supports Docker, for example, like Railway as well. So the costs are much lower as well. which can matter when the project is at the very early stage, or is it still just an experiment, as is often the case with the vibe-coded applications. Instead of managing and paying for 4 different separated services, a node server for Nuxt, Directus Cloud for backoffice, AWS Free, and MySQL, we can run everything together in the single Docker stack. And that might not be the best options for enormous applications, but for smaller apps and experiments like ours, it is efficient and good enough. And as a result, as you can see, the single command creates container for each layer, installs the required dependencies, and exposes the URLs needed to access the application. Compared with the traditional process of configuring each layer by hand, installing MySQL, preparing a node, and installing PNPM dependencies, this brings the whole setup at once. Developers don't need to run PNPM install or Composer install in their terminal while starting the local project. They only need to run one Docker command and everything starts up. And here's an example Docker configuration file that runs those layers at once. However, it's just for the general understanding. In my project, it's a little larger, so if you want to see the full configuration for this project or build stack like this yourself, refer to our technical documentation. I will add all the links in the video description. And in general, that's the foundation I'd reach for when a vibe-coded application starts to feel more like than just a prototype. A bit of structure early on makes the whole project more calmer to work with later, and in my experience it saves a lot of time once the application needs to grow, change, or be handed over to someone else. For this kind of project, I like the balance the stacks give us. Nuxt, Directus, MySQL, and RustFS keeps each layer in its place, while Docker makes the whole setup much easier to run and share. It feels like a practical starting point, but also the one that can grow with the project instead of fighting against it. Thank you so much for being here with me. I really appreciate your time and support, and honestly, it means a lot. If you enjoyed this video, I'd love if you had subscribed or shared it with someone who might find it helpful. And if you ever need developers who truly care about the work and about the quality of results, feel free to visit coditive.com or send me a message through the contact form. I will add all the links in the video description. So thank you again for your time and see you next time. Bye bye.